In the world of cataract surgery, there's this huge gap, right? There's knowing the steps, and then there's truly mastering the art. Today, we are going to bridge that exact gap. We're diving deep into the science of phacoemulsification, and we're going to turn all that theory into pure surgical instinct. Let's jump in. So, what's the real difference between a surgeon who's just competent and a true master of the craft? I mean, it's not just about having steady hands or knowing the procedure by heart. It's something deeper. It's about developing an intuition, kind of like a sixth sense for the machine that's in your hands. And that sixth sense, it has a name: Phacodynamics. This is the absolute key to unlocking that next level of skill. It's what turns the phaco machine from just a tool into a seamless, natural extension of your own hands. So let's unpack this so-called secret weapon. What exactly is pharmacodynamics, anyway? At its very core, phacodynamics is a balancing act. It's really the physics of how ultrasound energy breaks up the lens, how fluids are flowing in and out of the eye to keep everything stable, and how all of that interacts with the super delicate anatomy of the eye itself. It's a dance, really. Okay, now let's get practical. I want you to stop thinking of the phaco console as some complex, intimidating computer. Instead, think of it as a set of simple dials and levers that give you direct, real-time control over the physics happening inside the eye. First up, let's talk power modes. You've got continuous mode, which is kind of like a precision sander. It gives you this constant, smooth stream of energy that's perfect for sculpting. But burst mode, oh, that's your jackhammer. It's a powerful, intermittent blast of energy that's just perfect for impaling and getting a grip on a really dense nucleus. But look, it's not just about raw power. It's also about rhythm. And the duty cycle is what controls this rhythm. It basically defines the percentage of on time versus off time for the ultrasound. It's all about how that power is being delivered. And why does this matter so much? Well, a standard 50% cycle gives you nice, balanced cutting. But if you lower that duty cycle, you increase the off time. This does two amazing things. First, it creates a cooling period, which is absolutely crucial for preventing wound burn. And second, it seriously improves followability, that awesome magnetic effect where fragments are literally drawn to your tip during that off phase. All right, let's move on to our next key lever: vacuum. This is the force that grabs and holds, or occludes, lens material right against your phaco tip. And we measure it in millimeters of mercury. Honestly, the best way to think about vacuum is as your grip strength. It's all about how firmly you can hold on to a piece of the nucleus once you've got it. So when do you need a death grip versus just a light touch? Well, for a really hard nucleus that you need to crack, you need high vacuum. We're talking over 400 millimeters mercury to get a solid, unshakable hold. But when you're just sculpting or working near that delicate posterior capsule, you dial it way down to avoid accidentally grabbing tissue you really don't want to grab. Okay, so if vacuum is your grip strength, then aspiration flow rate, or AFR, is the force that actually brings the material to you. It measures how quickly fluid is being pulled out of the eye in cubic centimeters per minute. And this is the perfect way to picture it. Think of AFR as your magnetic pole. It's what attracts all those distant little lens fragments and just reels them into your phaco tip. Getting the difference here is absolutely critical. Flowability, which comes from AFR, is that magnetic pull bringing fragments to you. Holdability, which comes from vacuum, is the grip strength that holds them there. A true master surgeon is instinctively balancing these two forces all the time without even thinking about it. So understanding these forces is one thing, but what happens when they get out of control? Let's talk about surge. It's one of the biggest and, frankly, scariest safety challenges in phacosurgery. Let me tell you the story of a surge. First, your tip gets completely blocked by a dense piece of nucleus. Second, the vacuum in your tubing builds and builds until it hits its max setting. Third, that piece of nucleus suddenly breaks free. And fourth, bam, the high vacuum instantly sucks fluid out of the eye way faster than it can be replaced, and the chamber just collapses. It is a terrifying moment, and it puts the posterior capsule at serious risk. Okay, deep breath. The good news is we can prevent this. Modern machines are amazing. They use stiff tubing that doesn't collapse, tips that have a tiny bypass hole to prevent a total seal, and active fluidic systems that instantly counteract any pressure drops. But you can also do it manually. Just lower your vacuum settings for those risky moves, or simply raise your infusion bottle to increase the inflow pressure. Simple fixes, big results. The type of pump you're using also makes a huge difference. A peristaltic pump is generally safer. It only builds vacuum when you're actually occluded, which naturally reduces surge. A venturi pump, on the other hand, is a speed demon. It has instant vacuum and incredible followability, but it's also more greedy, you could say, and it takes more expertise to handle it safely. Okay, now let's see how all this physics translates into an actual surgical playbook for the main event, cracking that nucleus. You basically got two main philosophies here. Divide and conquer is the classic. You sculpt these deep trenches, then you crack the nucleus into quadrants. It's super safe, very controlled, perfect for beginners. Then you have direct chop. Here you don't do any sculpting. You use high vacuum to impale the nucleus and then use a second instrument to mechanically split it. It is way faster and uses far less energy, but man, it requires a lot more finesse. And that brings us to our final section, the masterclass. This is where we put everything we've just talked about together and see how an expert adapts to whatever challenge is right in front of them. So, here it is, the ultimate question. How do you look at a patient's cataract and instantly know what numbers to dial into your console? How do you build your whole strategy before you even make the first incision? This right here is the expert's game plan. For a soft kind of gummy bear nucleus, you want to avoid what's called cheese wiring, so you use low power and pretty medium vacuum and flow. But for a hard rock-like nucleus, it's a completely different story. You need high power and burst mode just to get into it, and you need maximum vacuum to get the grip strength to chop it, all while raising the bottle height to prevent that surge we talked about. See, two totally different strategies for two totally different challenges. So we've covered the physics, the safety, and the strategy. We've laid out the entire playbook from the console right to the cornea. So the final question, that one's for you. Knowing what you know now, which one of these parameters, power, vacuum, or flow, are you going to focus on mastering first on your own journey from competent to expert?